everyone. I hope you all are fine and you understood my first lecture on thermodynamics. Students, if you have not gone through that video, then please first watch that video. Only then it will be possible for you to understand this one. Okay, so today I'm here with two more topics related to chapter 1, first law of thermodynamics of unit 8, that is thermodynamics. Let me recapitulate the previous topic. Students, we have studied about thermal equilibrium, we have studied about zeroth law of thermodynamics, and we have studied about some very important definitions like thermodynamic system, thermodynamic variable, and some very important processes like isothermal process, isobaric process, isochoric process, and adiabatic process. If still you are not clear with definitions, then please go back and watch that video. Okay, I will share link in description box also. You can go through description box also if you want to watch my first video. Okay, so let us start. Our two topics are work done during expansion and first law of thermodynamics. In my last lecture only, I told you that expansion means the increase in volume. Okay, means volume is increasing, it is expanding. So what is the work done during this expansion? So students, for this we have taken one cylinder. Everyone has seen cylinder at your home, and you have seen that in cylinder there is one piston. Piston means the enclosure part from where you have closed your cylinder. Okay, so here also we have taken a cylinder which is containing gas. And which type of gas? Any gas. Okay, because all gases are expanding. Gases means the particles are very far from each other. You know, in gases the particle distance is very large as compared to liquids, as compared to solids. So we have taken a gas in a cylinder having frictionless piston. Frictionless piston means, students, that the piston may go up with the pressure. Okay, this is not a case that the piston is fixed and it cannot move. It can move. It is frictionless. Okay, and weightless also. So it undergoes expansion. Obviously frictionless, then what gas molecules will do? Gas molecules will push the piston in upward direction. So the gas is expanding from A to B. So you can see A, B. So gas is expanding from A to B. A और B के बीच में दो point और देख सकते हैं आप, small a and small v. So we are taking that suppose at any instant. At any instant means at any time we have checked that the gas was expanding from small a to small v. From here to here it was expanding, and the distance is here dx. Distance is here dx. You can see at point A the pressure was P and volume is V. But at point B the pressure is P. But volume gets changed from V to V plus dV. Means volume is increasing. Expansion. So what is the work done? Students, you know that work is equal to force into displacement. You have studied in 9th as well as in +1 standard. That work done is equal to force multiply displacement. Okay, and force is equal to pressure into area. Into displacement, pressure we denote by capital A, area you can denote by small a also. Displacement means how much displacement is in this region, dx. Students, area into displacement means A into dx is volume. If small distance is there, so small volume would be there. So dw is equal to pdv. If we want to calculate total work done, this work done dw is from here to here only, from small a to small v. If we want to calculate total work done from capital A to capital V, we need to integrate. So w will be equal to integration of p dv from v1 to v2, because at A the volume is v1, at B the volume is v2. So students, this is the expression for work done during expansion. Okay, so I hope that work done during expansion is clear to you all. Now we will switch over the next topic, that is first law of thermodynamics. Students, first law of thermodynamics in chemistry, you have studied that energy can neither be created nor be destroyed, but it can be changed, it can be transferred from one form to another form. Okay, that's okay, but in physics you need to write the first law of thermodynamics in this statement, as you can see on board. Okay, you have to write in this form only. If you will write that simple definition, that is also not incorrect, this is also correct, but its alternate definition is used in physics, that is, according to first law of thermodynamics, the amount of heat added to a system is utilized in two ways: to increase its internal energy and to do external work. Means whatever heat you will add in a system, then that will be utilized not in one work, it will be utilized in two works. And what are those two works? Increase in its internal energy, इसकी internal energy को increase करने के लिए, and to do the external work, और कुछ काम करने के लिए. Work means to expand something, to contract something, so that is the work. So mathematically, small heat is added, so dq is equal to du plus dw. This relation is very important. dq is equal to du plus dw, and dw, from that expression you can see dw is equal to pdv, so put it here, dq is equal to du plus pdv. So sign conventions you need to keep in mind, that work done by the system, if your system is doing work, it is positive. If work is done on the system, then it is negative. Okay, so this is first law of thermodynamics, which is equivalent to conservation law of energy or law of conservation of energy, which you have studied in your 9th standard. So students, once again I am telling you that first law of thermodynamics is equivalent, means barabar hai, it is equivalent to conservation of energy. But this doesn't mean that whenever I will ask first law of thermodynamics, you will write the definition of conservation of energy. Okay, you need to write this definition, that according to first law of thermodynamics, the amount of heat which is added to the system is used in increasing its internal energy and to do the external work. Okay, if mathematically also you are writing, you will get marks but not full. Okay, like dq is equal to du plus dw, if only this line you are writing, you will get only half marks. Okay, you need to write definition as well as mathematical explanation. So this is enough for today. Thank you. Have a good day.